The universe is vast, stretching beyond our wildest imaginations. It's a canvas of unimaginable size and wonder, filled with mysteries waiting to be uncovered. Billions upon billions of stars fill the night sky, each one a potential beacon of life. Many of these stars have planets orbiting them, and some scientists believe those planets could harbor life, perhaps even intelligent life. Imagine that, entire worlds teeming with creatures and plants, perhaps even intelligent beings like us, living in ways we can only dream of. The possibility is thrilling, but it also leads to a perplexing question. If the universe is so full of potential for life, where are all the aliens? Why haven't we found any evidence yet? This is the crux of the Fermi Paradox, a question that has puzzled scientists for decades. It's a captivating puzzle that highlights the contradiction between the high probability of extraterrestrial life and the lack of evidence for it, a mystery that continues to challenge our understanding. This paradox has intrigued scientists, philosophers, and the public alike, fueling countless debates and inspiring numerous works of science fiction, from books to movies. The universe seems ripe with possibilities, but the silence from the cosmos can be deafening, leaving us to wonder about our place in the vast expanse of space. The Fermi Paradox is named after the brilliant physicist Enrico Fermi. In 1950, during a casual lunchtime conversation, Fermi posed a simple yet profound question to his colleagues. Where is everybody? He was referring to the lack of evidence for extraterrestrial civilizations, despite the vastness of the universe and the high probability of life existing elsewhere. Fermi's question wasn't just a passing thought. It was rooted in his deep understanding of physics and the scales of the universe. He realized that even if only a tiny fraction of stars harbored planets with intelligent life, and even if only a tiny fraction of those civilizations developed interstellar travel, the galaxy should be teeming with alien visitors. Yet, there was no conclusive evidence to prove their existence. This apparent contradiction sparked a wave of scientific inquiry that continues to this day. One possible answer to the Fermi Paradox is that we are truly alone, or at least exceptionally rare. This is the premise of the rare Earth hypothesis, a theory that has intrigued scientists and astronomers for decades. It suggests that the conditions required for complex life to arise are so incredibly specific and improbable that Earth might be the only planet in the Milky Way, or even the entire observable universe capable of supporting it. Think of all the factors that had to align perfectly for life to flourish on our planet: the right distance from the sun, the stabilizing influence of our moon, which helps regulate our planet's tilt and seasons, the protective shield of our magnetic field, which deflects harmful solar radiation, the presence of liquid water, essential for all known forms of life, and the list goes on, encompassing countless other factors like plate tectonics and a stable climate. If even one of these factors were slightly different, the story of life on Earth could have taken a completely different turn, potentially making our planet uninhabitable. The rare Earth hypothesis argues that such a perfect storm of conditions is astronomically unlikely to occur elsewhere, making Earth a unique and precious anomaly in the vast cosmos. Another possible explanation for the Fermi Paradox is the Great Filter hypothesis. This theory posits that there are various barriers or filters that prevent life from evolving to an advanced, spacefaring stage. These filters could be anything from the early formation of life itself to the development of intelligence, technology, or the ability to avoid self-destruction. The Great Filter hypothesis has some unsettling implications. If the filter lies in our past, then it suggests that we are incredibly fortunate to have overcome it, and that the path to intelligence is incredibly rare. However, if the filter lies in our future, it implies that there is some existential threat that prevents civilizations from reaching a certain level of advancement. This threat could be anything from nuclear war to climate change to some unknown cosmic phenomenon. Section 5. The self-destruct button, a sadly familiar tale. The self-destruction hypothesis offers a rather bleak explanation for the Fermi Paradox. This theory suggests that intelligent civilizations might have a tendency to destroy themselves before reaching a stage where they can make contact with other worlds. Given humanity's own history of conflict, environmental degradation, and the looming threat of climate change, this possibility is not as far-fetched as it might seem. Think about the weapons we've created, the damage we've inflicted upon our planet, and the challenges we face in simply coexisting peacefully. These issues are not unique to humanity. It's conceivable that other intelligent species might face similar challenges, and some might not be as fortunate to overcome them. Section 6. Hidden in plain sight. The invisibility of advanced civilizations. The technological invisibility theory proposes that advanced extraterrestrial civilizations might be so technologically superior to us that we wouldn't even recognize them if we encountered them. Imagine trying to explain the internet to an ant. The ant simply lacks the framework to comprehend such a concept. Similarly, we might be like ants when compared to a Type 3 civilization on the Kardashev scale, a civilization capable of harnessing the energy output of an entire galaxy. Their technology could be so advanced that it would appear indistinguishable from magic or natural phenomena to us. We might be surrounded by their activities without even realizing it. Section 7. The zoo hypothesis. Are we under observation? The zoo hypothesis presents a rather unsettling possibility. What if we are not alone, but are being deliberately kept isolated from more advanced civilizations? This theory suggests that Earth might be treated as a kind of cosmic wildlife preserve, with extraterrestrial observers choosing to observe us from a distance without interfering. The reasons for such isolation could be varied. Perhaps they are studying our development, waiting for us to reach a certain level of technological or ethical maturity before initiating contact. Or they might be protecting us from some unknown threat in the galaxy. Whatever their reasons, the zoo hypothesis raises intriguing questions about our place in the cosmic pecking order. Section 8. Searching for whispers in the cosmic ocean. Despite the lack of definitive proof, the search for extraterrestrial intelligence, or SETI, continues to captivate our imagination. Scientists around the world are employing increasingly sophisticated technologies and strategies to listen for any signs of alien civilizations. From powerful radio telescopes like the Arecibo Observatory to space-based observatories like the James Webb Space Telescope, we are constantly scanning the cosmos for any unusual signals that might indicate an artificial origin. Additionally, space probes like Voyager 1 and 2, now venturing beyond the outskirts of our solar system, carry messages from Earth in the hope that they might one day be intercepted by an alien civilization. Section 9. Alone in the vastness. The Fermi Paradox is a sobering reminder of the vastness of our universe and the profound mystery surrounding our place in it. It questions why, given the high probability of extraterrestrial civilizations, we have yet to encounter any signs of them. Despite the high probability of extraterrestrial life, we have yet to find any conclusive evidence of its existence. This paradox challenges our understanding of life and the universe, whether we are truly alone, separated by unimaginable distances, or simply not looking in the right way. The question of where is everybody continues to echo through the corridors of science and philosophy. It is a question that has puzzled scientists for decades. Perhaps one day we will have a definitive answer to the Fermi Paradox. Advances in technology and space exploration may bring us closer to understanding our place in the cosmos. Until then, the search for extraterrestrial intelligence serves as a testament to our insatiable curiosity and our enduring hope that we are not alone in this vast and wondrous universe. Our quest to find other intelligent beings continues to drive scientific discovery. The silence of the cosmos can be deafening, but it also fuels our imagination. and inspires us to keep exploring the great unknown. It is this silence that pushes us to look deeper and dream bigger.